So looking at part 2 of this example, I see again an integral from 0 to 2 and 5x, and I see a square root of x squared plus 3. And the idea is, again, radicals in this chapter are always bad. So we don't like having a square root. So what we're going to do next is find a way to rewrite the problem without the radical. And that's very straightforward in this case. We just give it an exponent. And the exponent is going to be basically 1 divided by 2. So we did that in a different problem, but that's the same trick that I'm using. And now let's make the u substitutions. So the u is going to be, in this case, x squared plus 3. The derivative of u is going to be 2x dx. And if x is 0, which is the number on the bottom of my integral, what would the u be? If x is 0, then the u is going to be 0 squared plus 3, which is going to be 3. And if x is 2, the u is going to be 2 squared plus 3, which is 4 plus 3, which is basically 7. Okay, so now the trick is to notice right here that it says 2x dx, not 5x dx. So what are we going to do? Here's what we're going to do. The plan is to get the 5 out of there, write it on the outside, leave the 0, leave the 2, leave everything else unchanged. So the x squared plus 3 with the power of 1/2. The x, leave everything unchanged, but notice how we need a 2. So we'll put a 2 there because that's the number we need, and we'll just throw an extra 2 on the denominator to balance it out. And that's pretty much my setup, and it's now ready to go. So let's see. U is going to replace the variables x cubed plus 3. So anytime you see x cubed plus 3, you're going to write down the letter u. And the u is going to be replaced with the 2x dx. So anytime you see 2x and a dx, write down the variables du. And also, anytime you see x equal to 0, write down 3. So instead of 0, we're going to put a 3. And finally, instead of the 2, we're going to write down 7. So let me use a different color for that. Instead of the 2, we're going to write down 7. So instead of 2, we're going to put 7. So there's the setup with all the changes being made. And now I'm ready to do the antiderivative. So the antiderivative of u to the 1/2 is going to be u to the power of 3/2 divided by 3/2. Instead of plus c, we're going to put the 3 and the 7. And now we're basically required to do a fundamental theorem of calculus part, whatever. So let's see. First of all, 2 times 3/2 is going to be 3 because they cancel out. So we're going to get 5/3 u to the power of 3/2. And that's going between 3 and 7. So let's plug in the 7 and let's plug in the 3 and see what happens. So plug in the 7, plug in the 3. And unfortunately for this one, when you plug it in your calculator, the answer is going to be an ugly decimal. So typically speaking, when the answer is an ugly decimal, we leave it like this. But if you want to know what the decimal is, let's switch over to the calculator screen and see what it looks like when we plug it in. So turn on your calculator again and click Math 9, and then you're going to need to type in the expression 5x and then the radical, so square root of the x squared plus 3. Close the parentheses of the radical, then put the variable x, then put the lower bound, then put the upper bound 2. And there's the decimal version, and if you click Math 1 to try to make it into a fraction, the calculator will not be successful to do that. So that's the reason why I had to work it out by hand and get the solution done by hand, because there is no way on earth this can be written as a fraction. Oh well, it is what it is.